Hello everyone, welcome to Neso Academy. I am your instructor Vivek Sharma and today we are starting a brand new course called VHDL Programming under a new series, VLSI series. Over here, VHDL stands for Very High Speed Integrated Circuit Hardware Description Language. It is one of the most important languages used for digital system design, FPGA development, and VLSI design. This is the very first lecture of VHDL programming course, and the name of the lecture is Introduction to VHDL. In this introductory lecture, we will understand the overview of the course. So, in this lecture, we will discuss the following topics. The very first topic is Need for VHDL. In this section, we will understand why VHDL became necessary for digital system design and how it helps engineers to describe complex circuits more efficiently. After that, we will see the syllabus of the course, and in the last, we will see our target audience. Along with the target audience, I will also tell you the course highlights. So, these are the topics we will cover in this lecture. So let's start with the very first topic, need for VHDL. Earlier, before HDLs or any hardware descriptive languages were introduced, digital circuits were designed using schematic diagrams and manual hardware design methods. Engineers used to manually draw the circuits consisting of logic gates, comparators, registers, and many other components. And these schematic diagrams represents the entire hardware. Now, this method worked well until the circuits were small and simple. However, as digital systems become more complex, containing thousands or even millions of logic gates, managing and modifying these schematic diagrams becomes very difficult. For example, imagine drawing a microprocessor or a communication system using schematic diagrams only. It would require enormous number of gates and interconnection. In such cases, designing becomes very difficult, debugging becomes complex, and modification becomes very time consuming. And because of this increasing complexity, engineers needed something new, something more efficient for digital system design. And this is where VHDL came into picture. VHDL allows engineers to describe digital circuits using code, which can then be simulated, tested, and implemented in hardware. Now, what that mean? It means instead of drawing the diagrams, engineers write code. Now, these code describe the behavior and the structure of the circuit. Therefore, the name of the language is Hardware Description Language. And after the code is written, the same code can be tested on multiple simulation tools. And after successful simulation, our last step is hardware implementation. Let us understand this using an example of a half adder and see the basic design flow of VHDL-based digital design. The very first step is VHDL coding. Over here, we have a half adder. Now, we all know that a half adder is made using XOR and AND gate. Now, the logic is created using VHDL code. The code will act as a blueprint for the hardware. Now, our second step is simulation. Over here, different input signals are applied in a design, so output can be observed. If the output matches with the expected results, then we can say our code is correct. If not, then we need to debug and modify the code. Then our last step is hardware implementation. Over here, the same VHDL code is converted into actual hardware configuration. Now, using this flow, engineers can design, test, and implement difficult hardware circuits. Now, if you ask me why VHDL became so much necessary, there are multiple reasons. The very first reason is VHDL is used in digital hardware design. Starting from college level projects to modern electronics product, VHDL is very essential for designing complex circuits more efficiently. Next, VHDL enables pre-hardware simulation. Now, simulation allows to check whether our code is correct or not before a proper actual hardware implementation. Now, this is a very important advantage because it saves both time and cost. And after a code is written, the same code can be used for field programmable gate arrays, which is FPGA, and complex programmable logic devices, which is CPLD. Now, using these devices, engineers can implement custom digital designs over manufacturing a new chip because FPGA and CPLDs are reprogrammable devices. Now, what that means? It means that multiple VHDL codes or multiple digital designs can be implemented or can be tested on the same hardware. Now, this is very useful for the industries. Therefore, learning VHDL is very important skill in order to build career in VLSI, embedded system, and in FPGA development. That's why VHDL play a very crucial role in modern digital electronic system. So I hope you now understand the need for VHDL. In this way, we have completed our first topic, need for VHDL. Let's see the syllabus of the course. The syllabus of the course is very carefully designed so that a student can learn VHDL step by step, starting from basics and moving on towards advanced topics. I have divided the syllabus into multiple chapters. The very first chapter is Introduction to VHDL. Including this lecture, we will cover multiple more topics in this chapter, like basics of VHDL, history of VHDL. We will also see difference between VHDL, Verilog, and C programming. Then, our second chapter is Structure of VHDL programming. In this chapter, we will understand the basic structure of VHDL programming, which mainly consists of entity, architecture, library packages, and library declaration. Then, our third chapter is data types and objects in VHDL. There are different types of data used in VHDL programming, like standard logic type, integer type, bit vector types. After this data type topic, we move on to see VHDL objects, such as signals, variables, and constants. Then, our next chapter is operators and statements in VHDL. Just like any other programming languages, VHDL also uses operators. For instance, arithmetic operators, logical operators, and relational operators. After that, we will see statements in VHDL, which defines how operations are performed within the program. Then our fifth chapter is modeling styles in VHDL. One of the powerful features of VHDL is that we can describe a hardware using different modeling styles. And the different modeling styles are behavioral modeling, data flow modeling, and structural modeling. Then our sixth chapter is combinational circuits using VHDL. In this chapter, we will design combinational circuits like multiplexers, encoders, decoders, adders, subtractors using VHDL programming. Now, you must have guessed the next chapter, which is sequential circuits using VHDL. Sequential circuits like flip-flops, latches, counters, which not only depends on current input but also on the previous states. We will design those circuits using VHDL programming. Then our next chapter is finite state machines using VHDL. Now FSM is widely used in digital systems like in control units, in communication protocols, and in embedded systems. And finally, our last chapter is test benches in VHDL. Now test bench is used to verify the VHDL code. So a test bench plays a very crucial role in design verification before hardware implementation. So these are the 9 chapters we are going to cover in this course. In this way, we are done with the syllabus part. Now let's see our final topic, which is target audience. Now the question is, who should learn this course? This course is mainly designed for college students or university-going students who are learning VHDL as part of their curriculum. This course is also very suitable for the beginners who wants to learn HDL design from the start. If you have basic knowledge about digital electronics, you will easily understand this course. This course is also very suitable for the students who are preparing for VLSI, FPGA and embedded engineering jobs because VHDL is widely used language in hardware industries. Even if you want to learn VHDL for fun's sake and if you are interested in designing hardware system, this course is very beneficial for you. Now, we are done with the target audience, but as I mentioned earlier, I will also tell you the course highlights. So the very first highlight is topic-wise lectures. The entire course will be divided into short and topic-specific lectures so that each and every concept can be easily understood. The second highlight is simple, intuitive explanation. Every concept will be explained in clear and in detailed manner, so even a beginner can learn VHDL very easily. Our third highlight is exam-oriented concepts. Important concepts which are frequently asked in university examination will be cleared here in detail. Finally, we will be providing you examples, quizzes and notes. And if you want this material, you can get them by visiting our website or by downloading our application. So these are the course highlights, which means we are done with our final topic, target audience. So I hope you are enough motivated to start this VHDL journey with me. Now we are done with this lecture. I will see you in the next one. Thank you.